Well, my name is Robert. I've been a public math teacher, a public school math teacher for many years. This is a free Algebra 1 math class for those who wish to refresh their algebra skills. So, thus far, we've been reviewing all of our pre algebra skills that we need in order to be prepared to be successful with the algebra content. So, we've looked at different sets of numbers, the natural numbers, which are whole positive numbers and zero, integers, which are positive and negative whole numbers and zero, rational numbers, any number that can be written as a fraction is a rational number, and real numbers that include numbers that are decimals that go on forever but do not repeat, like pi. Then we also looked at evaluating expressions. We remembered the mnemonic device, please excuse my dear Aunt Sally. And so we go from left to right, parentheses, exponents, multiplication, division, whichever you see first, and then addition or subtraction, whichever you see first. We also looked at converting fractions to decimals and decimals to percentages, percentages to decimals, and decimals to fractions. All that good stuff. And then we also looked at evaluating exponents. And so we didn't just look at our normal exponents, which are positive whole numbers, like 6 to the third power, for example. We also looked at what happens if we have 0 as our exponent. And we saw that any number raised to the 0 power is 1. Also, we looked at negative exponents, which means that we simply make whatever our base is into a fraction if it's not already a fraction, and then the numerator or the denominator flips. So we go ahead, raise the base to a power, and then we flip the numerator and the denominator. Now, if we have a fraction as an exponent, then we look at the denominator and we make that many boxes, and then we raise that to the power of the numerator in the fraction that's the exponent. We also looked at just different terms that we needed to be able to define because they're important and will be important as we go forward. So that includes variable, which is a letter or multiple letters that represent some quantity that may change or is unknown. We also looked at a term, which is a number or a variable with a coefficient. The coefficient is 1 if you don't see a number. And we looked at combining like terms, which means that if we are wanting to add or subtract variables, then they have to have the same base and they have to have the same exponent. If the exponents are different, then we cannot add them. And so we looked at those definitions. Then we also practiced evaluating expressions. So now we're going to look at solving equations. A solution to an equation is a value which when it replaces the variable, makes the equation true. For example, let's say I have x plus 4 equals 10. Well, what number can I put in the place of x that when I add 4 to it will equal 10? Obviously, 6. So 6 is a solution to that equation. 6 plus 4 gives me 10. To solve an equation, we use the opposite of the order of operations. And here I'm specifically talking about especially the multiplication and division and addition and subtraction. And we must remember that whatever we do to one side of the equation, we must do to the other. Otherwise, we have changed the equation. So let's look at some one-step equations. And remember, we do the opposite of the operation. And we do that because we want to isolate the variable. We want to find out what is x. So we need to get 1x by itself on the left-hand side, and then an equal sign, and then see what one of these x's is. So let's say I have 3x equals 27. again, if I have a coefficient in front of a variable, then that's multiplication. So that means that I'm multiplying the variable times 3, and when I do that, I get 27. So 3 times what number is 27? And so that's the question. So we know the number in our head. We can do that in terms of mental math, but what we really want to do is to just practice solving these one-step equations. So what do I need to do to get x by itself? I need to divide both sides by 3. If I only divide by 3 on one side, then I change the equation, and so it's not the same equation, and I haven't solved it. So 3 times x equals 27, I divide both sides by 3, and I get x on the left-hand side, and 27 divided by 3 is 9, so that means x equals 9 is my solution. What if I have 7x equals 35? Again, I asked myself, well, what operation am I seeing here? Multiplication. Because again, I have a coefficient in front of a variable. So that means I'm multiplying x times 7, and I'm getting 35. So that means I need to divide by 7 on both sides. So 7 divided by 7 is, of course, just x. So that's how I can get x by itself. I do it to the right-hand side of the equation as well. 35 divided by 7 is 5. So the answer is x equals 5. Okay, so what if I have something like x divided by 5 equals 8? So that seems kind of tricky, right? Because when I see division, but what am I actually doing here? I'm dividing by 5. So what's the opposite of division? It's multiplication, right? So I just need to multiply both sides by 5. So if I do that, then I'm going to end up canceling out the 5s, and I have to do it to the right-hand side as well. So 8 times 5 is 40. So 40 divided by 5 is 8. So this is also a way to check to make sure I have a correct solution. Now, what if I have something like 3/5 x equals 9? Okay, so now maybe that seems more complicated, but it's really not. So if I have 3/5, then what's the multiplicative inverse of 3/5? So it would be 5/3, right? So all I'm trying to do is flip the fraction to get the inverse. So if I multiply 3/5 times 5/3, well, what do I get on top? 3 times 5 is 15. And what do I get in the denominator? 5 times 3 is 15. So by multiplying it times 5/3, then I am eliminating my coefficient, and I only have 1x, right? 3/5 x times 5/3. Well, the 5's cancel out, the 3's cancel out. That just leaves x by itself. But again, I have to do that to the other side as well, or else I've changed the equation. So 9 times 5 over 3. Well, 9 divided by 3 is 3. 3 times 5 is 15. So that would be my solution. So 3/5, 15, and if I if I replace x with 15, then this works, right? 3 times 15 is 45. 45 divided by 5 is 9. So these are some examples of one-step equations that we solved, and there are some others that are simple as well. I'll do, let's say, a couple more, and then we'll go from there. So, what if I have x plus 5 equals 12? So, what do I have in that equation? Uh, I have addition, right? So, what's the opposite of adding 5? Subtracting 5. So I subtract 5 from both sides, and I get x equals 7. Now, let's look at one that's a couple more that are maybe more tricky. Here, we'll just do one more. X to the 2/3 power equals 4. Let's say we do that. So, how do I get rid of my exponent now? Because now it's 2/3. Well, what I want to do is actually just raise it to the 3/2 power, and by doing that, then my exponent becomes 1. And why is that? Because when you raise one power to another power, it's the same thing as multiplying the exponents. So multiplying the exponents, 2/3 times 3/2 would give me 6/6, which would be 1. So by raising the x to the 2/3 power to the 3/2 power, then I'm getting x by itself, which is what I want. So I have to do it also to the other side. And if I do that, then I have 4 to the 3/2 power. Now, the denominator of the fraction is 2. So that since I have a fraction exponent, then I have to draw the number of boxes that's in the denominator. So one box times another box equals 4. What number goes in the box? 2, obviously, right? 2 times 2 is 4. So 4 to the 1/2 power is 2. So now I've dealt with the denominator. So now I just need to use the result from that, the 2 that I just obtained, and raise that to the power that's in the numerator. So 2 to the 3rd power is, of course, 8. So it's that was still just a one-step equation. So these were some problems. Hopefully they were helpful, and so hopefully working with these one-step equations that this has been helpful, and I look forward to seeing you again next time. Thank you and have a great day.